In today's class, we will discuss about the chapter called Metrology. Okay. So in this chapter, we will come across different measuring instruments and also its working principles and very new terminology will be there in the chapter called metrology. So before going ahead with this chapter, we will have the understanding of measurements. First I will tell you about measurements. What is measurement? Measurement is any dimension that can be measured with the help of any specified instrument called measuring instrument. Okay. So if you look broadly into the classification of measurements, there are three types of measurements. Okay. First one is linear measurements. Okay. That means measurements which are to be measured in the line direction. Okay. For example, a straight line having a 100 centimeters length. This you have to measure. So for measuring this type of linear measurements, we have separate measuring instruments like steel rule. Our day-to-day life measuring instruments like what you can say some drafters. Other instruments are also widely used for measuring linear measurements. Again in the linear measurements, okay, there are two types of measurements are there. First one is line standards, as I told just now, which will be measured with the help of steel rule. And the second one is end standards. The best example for this end standard measurement is a cylindrical rod of 10 mm diameter having a length of 50 mm. So if you want to measure the length of 50 mm of a cylindrical rod, then if you take the simple steel rule, it is not possible to measure the length of a steel bar. In that case, we will go for another measuring instrument called micrometer. So this micrometer, what it will do is, it will hold both ends of the circular rod and it will take the reading, thereby the length of the circular rod will be measured. This is all about the linear measurements. Okay. So why I am discussing the types of measurements is why, because our chapter metrology is entirely deals with the measurements. So metrology, if you want to define the term metrology, metrology is science of measurements. Science of measurements. So metrology is a science of measurements. Metrology is a different another science which is used for measuring the various sizes, etc. Okay. If you go for higher studies, the same metrology is having the separate subject, whereas in our diploma level metrology is a one chapter. Okay. So in that way, metrology is having its own importance, so that we should not ignore any point in this chapter called metrology. Okay. Coming back to the metrology, what will happen? We discussed about linear measurements, then we will go for the angular measurements. So you want to measure an angle between two sides. So for in that case, for measuring the angles, again we have different types of instruments like bevel protractor. So you will see in your day-to-day life as a diploma engineer, in your compass, in your compass box, you will definitely find a bevel protractor to draw the angles or curves, etc. with curves with an angle. Okay. So there is no much need to explain about bevel protractor for measuring the angles. Another instrument for measurement of angles is sine bar. Sine bar is used to measure the angles, okay, by taking into consideration of sine theta. That is the reason only the instrument is named after sine bar. It is a bar, but it is a inclined bar. When it is placed on a work table, it is in the inclined bar. So it is having rollers on the top. It is having rollers on the top. It is having rollers on the top as well as in the bottom. So the distance between the rollers is our hypotenuse. Okay. And alongside the sine bar alone cannot measure the angle between two sides. Sine bar will take the assistance of slip gauges, okay, to measure the angle of two given sides. So again here comes the terms called slip gauges. So we need to have the full understanding of slip gauges. So before explaining in detail about sine bar, we will have a discussion about slip gauges. Okay, slip gauges are those gauges which are standard in nature of different thicknesses like 2 mm, 5 mm and 10 mm like this. Okay. Strictly speaking, these are the rectangular blocks. On the upper surface of the slip gauges, it is written as 2. On the upper surface of the slip gauges, it is written as 2. Number 2. Number 2 indicates the thickness of that particular slip gauge can measure. That means only up to 2 mm thickness that particular slip gauge can measure. Likewise, number 5 is written on a slip gauge. That slip gauge will measure the only this 5 mm thickness, up to only 5 mm thickness. So like this, different types of thicknesses slip gauges are available in the industry. If you look at practically, all the slip gauges are manufactured in a section called tool room. If you take any manufacturing industry, there is a section known as tool room section, in which all these slip gauges will be manufactured, and on the top surface of the slip gauges it is marked as number 2 or number what you can say 5 or number 10. Okay, like this, slip gauges are taken into assistance by the sine bar for measuring the angles. So now coming back to the sine bar will not alone measure the angles. It will take the help of slip gauges. Then how it will take the help of slip gauges? Let us see. Alongside the sine bar, we are placing the sine bar on the work table. Then just alongside the sine bar, we will place the slip gauges of 5 mm. Okay. Then 2 mm. After that again 5 mm. That means we are placing the slip gauges one over the other, so that the final slip gauge will touch the top rollers of the sine bar. So let us assume that we need 10 slip gauges of different thicknesses to touch the top rollers of the sine bar. Okay, 10 slip gauges of different thicknesses, like 5 to 5 to, that is one set, again 5 to 5 to, that is another set, again 5 to is another set. 10 slip gauges. Here 5 to 5 to is 14, one set, another set is 5 to 5 to, that is 14, 28, another set is 5 to 7. So 35 mm is the height of the top rollers from the bottom line. If you draw a horizontal line along the axis of the bottom rollers, so from this horizontal line, so the distance, the height of the top rollers are 35 mm. Then we have the height, then the distance between the rollers is capital D. Then we will take theta. Sin theta is equal to opposite side by hypotenuse. Opposite side is h. Capital H is 55 divided by hypotenuse that is D, capital D. Capital D may be greater than, obviously greater than 55. Okay, it may be some 110. Okay, so if it is 110, what will happen? Sin theta is equal to 1 by 2. Then the angle is theta is equal to 30. Sin 30 is off. Sin 45 is off. Sin 30 is off. You can say like that. Okay. Then what will happen? Then what will happen? So in this way, the sine bar is used to measure the angles. Next, another instrument is to measure the angles is angle gauges. There are different types of angle gauges. Okay, which will be used to measure the small angles, right from the small angles to the very larger angles. Okay, this is all about the measurement of angles. Now we will switch over to the surface measurement instruments. The instruments which are useful in measuring the surface roughness of a given workpiece. So for this purpose we have what we can say, we have this first one is optical flat for measuring the surface roughness of a given object. There are different types of instruments. Among different types of instruments, 4 major instruments are widely used for measuring the surface roughness. First one is optical flat, second one is autocollimator, third one is profilometer, fourth one is interferometer. Okay. Then we will see one by one how these measuring instruments will be used for measuring the surface roughness of a given workpiece. First, let us have a look at the optical flat. As you know, optics deals with the light. Optical flat obviously uses a light source. From the light source, what will happen? Light waves will travel and it will hit the object and scatter back into the space by making an angle with the object. If the light waves will make a small angle with the object like 2 degrees or 3 degrees or less than 5 degrees, then we can say that that particular object is having a good surface finish, good surface roughness without any defects, like surface cracks, indents, etc. Okay. But if the light waves after this hitting the workpiece will scatter back with a by making a wide angle, then it is treated as that particular surface is having some surface defects like blowholes, blurs, surface cracks, etc. In that case, again that workpiece is taken back for machining process and super finishing operation will be carried out on the workpiece for getting the good surface roughness. Okay, this is all about the optical flat. One more important point here we have to note is optical flat is exclusively used for measuring the surface roughness of small size objects like needle, which will be used in tailoring process, and also intricate shaped objects like for threaded portions. If you want to measure the surface roughness of threads, then optical flat is the only instrument to measure the surface roughness of threads. Even in knurling process also, this optical flat is extensively used. Similarly, autocolorimeter is also there to measure the surface roughness. Interferometer is also there to measure the surface roughness. Another instrument like what we can say, optical flat, autocolorimeter, interferometer, and some other instrument is there. Okay, that is also used for the measurement of this surface roughness. Okay, then we will switch over to the comparators. Okay, so what is comparator? Comparator is a measuring instrument which is used to measure the given size and compare the measured size or known size with the standard size. This is the main function of the comparators. So, suppose 100 mm is the standard size set by the ASME, American Society of Mechanical Engineers. If the comparator is used to measure 100 mm size and the reading on the comparator shows only 98 mm, then that reading taken by the comparator is known as known size. 98 mm is the known size, 100 mm is the standard size. So the comparator will compare the known size of 98 mm with the standard size of 100 mm. Okay, this is the main usage of comparators. Again, to perform this operation, we have different types of comparators. Okay, broadly speaking, in the industry we have lot of comparators. Among them, 4 comparators are widely used in the industry. So the first comparator is mechanical comparator. Second one is electrical comparator. Third one is optical comparator. Fourth one is pneumatic comparator. So let us discuss one by one. Mechanical comparator, as usually it is robust in size. It requires a huge space. It is having a lot of components. Okay. So it will take long time to take the measurement. Okay, but the operating of the mechanical comparator is very much easy. Okay, this is all about the mechanical comparator. The second one is electrical comparator. Electrical comparators require less space when compared to mechanical comparators, and of course electrical comparators are costly compared to mechanical comparators, and these uh, these electrical comparators takes the reading with the help of electrical grids, and these readings are compared with the standard size. Okay, then we will switch over to the optical comparators. Again, in the optical comparators, as usual, this comparator utilizes the light waves to measure the given size, and after measuring the given size, it will compare the size with the known size. It will compare the known size with the standard size. So, in this way, an optical comparator will be used. Finally, pneumatic comparator. Pneumatic comparator utilizes compressed air, for measurement of given size. Okay, after measuring the given size, it will compare the known size with the standard size. So, out of all these comparators, pneumatic comparator is very cheap because it requires only air. So, air is available in abundant in the universe. So, no much cost is incurred for fabricating pneumatic comparators. Okay, and it is light in weight. Okay, but expertise is required to operate these pneumatic comparators because pressurized air is there in the cylinder. If the operator makes any mistake, then it will burst, thereby leading to the death of the operator. So, like this, we have different types of comparators to measure the given size and compare the known size with the standard size. This is all about the comparators. Then we will switch over to a new mechanical term known as calibration. You might not have heard about this term called calibration. Calibration is nothing but measurement of measuring instruments. Okay. So then comes a question in our mind that what is the need to measure the measuring instruments? There are already the measuring instruments. Then again, what is the need to measure the measuring instruments? This question usually rises in our mind. So, the answer for this question is all the measuring instruments, if you continuously use over a period of long time, what will happen? It will lose its accuracy as well as its precision due to wear and tear. Okay. So, over a longer periods, all the measuring instruments will not give the correct readings. will not measure the correct sizes. So, in that case, there is a need of calibration. Okay. So, calibration is nothing, is the process of measurement of measuring instruments. So, again one doubt will come across, sir, all the measuring instruments can be calibrated, because we have so many measuring instruments in the industry. Is it possible to calibrate all the measuring instruments? So, this doubt can be clarified like this. Suppose if you have optical flats, suppose we are having optical flats, 1000 numbers of optical flats in a big manufacturing industry. The 1000 numbers of optical flats can be treated as one, you can say one lot. So, out of one lot, which consists of 1000 numbers of optical flats, out of one lot we will pick only 5 optical flats for calibration purpose. If 5 optical flats will give the correct results after calibration process, then we will certify that the entire lot is okay for measurement purpose. Okay, the entire lot is accepted as okay, and the certificate is given to the entire lot of 1000 opticals. Okay, we will not calibrate all the 1000 optical flats. We will not calibrate all the 1000 optical flats. Rather, we will calibrate only 4 to 5 optical flats. Okay. If the 4 to 5 optical flats are performing very well, they are giving very good results, then we can say that entire lot of 1000 optical flats are treated in good condition, and they are assumed that it is assumed that remaining entire lot optical flats will give the good readings, provided if all the optical flats are manufactured in the same year. Okay. So, one lot consisting of 1000 optical flats, I said now, those 1000 optical flats are manufactured in a same year, called in the 2015. In 2020 we will go for calibration of 5 calibration for 5 optical flats only. Okay. That means all the 1000 optical flats will be were manufactured in 2005 model, so 2015 model only. Okay. In this way, we will calibrate only few number of measuring instruments, maybe optical flats or sine bars, whatever the instrument it may be. Okay. Then we will switch over to another interesting topic, that is known as the fundamentals of calibration techniques. Fundamentals of calibration techniques. See, every operator or every technician cannot perform the calibration process. because calibration process is not that much easy. It requires huge skill as well as the complete understanding of the measuring instruments. Okay, then only this calibration process is carried out. So, first of all, take any manufacturing industry, some of the employees are trained for calibration purpose only with the top notch institutes like Central Institute of Tool Design and other top organizations like CPET, Central Institute of Plastics Engineering and Technology. Okay, and renowned IITs and prominent universities. Okay, these will give training to the employees of different manufacturing units in calibration techniques. Okay, so after undergoing critical training of this calibration techniques, only they are certified that this particular operator is a calibrator. The person who the employee who performs calibration process is known as calibrator. So for the getting calibration certificate is not that much easy because here calibration involves measurement of measuring instruments. అంటే మెజరింగ్ ఇన్స్ట్రుమెంట్స్ని మళ్ళీ మనం మెజర్ చేయాలి అంటే అదంత ఈజీ ప్రాసెస్ కాదు కాబట్టి ఆఫ్టర్ క్రిటికల్ ట్రైనింగ్ ఓన్లీ బై ద డిఫరెంట్ ఏజెన్సీస్ ఫర్ ఎ డ్యూరేషన్ ఆఫ్ 2 to 3 months, then operator will learn how to calibrate. Even if the operator will do any mistake, then the entire calibration process will be a big waste. Okay, that's why major focus is that's why the major focus is on calibration techniques with reference to the metrology chapter. Okay, so if you are very well in calibrating techniques, then you are paid high. Like in software, if you know the coding very well, then you will be paid high. So in the similar fashion, the calibrator with a good skills, okay, in the industry, he will be paid high salaries and wages. Okay, so this is regarding the brief description about metrology. Okay, then some of the questions from this metrology or some of the doubts from this metrology chapter are is calibrating cost effective when compared to other techniques? Obviously not. Calibration requires lot of expenditure because all the employees need to undergo. That means employees who will calibrate the measuring instruments need to undergo the rigorous training in prestigious organizations or institutes, so that will incur huge expenditure. So obviously calibration process is a costly process. So in this way metrology, having its own significance in our day-to-day life also. So for example, if you go to in our day-to-day life, we are going to the market and we are purchasing some vegetables like tomato. We are purchasing 1 kg of tomato. So that 1 kg, so that is to be measured. It is to be measured. Okay. So that is a measurement. Okay. Then again in the construction industry also, okay, there are, if you construct a metro rail, this what we can say, if you want to construct a long bridge over a river, then metrology will come into picture. Okay. So because construction of any civil engineering structures will require measurements, will require taking the measurements. So in that case also metrology is useful. Okay. So if you take the metrology in a mechanical point of view, we will measure the small objects, varying from the small objects to the larger objects, varying from the small angles to the larger angles, and also the surface finishing operations. So this is all about the brief explanation about metrology. Then I'll give you few important facts that in your diploma level metrology is a one chapter, but if you go for higher studies, metrology is one subject. You do not believe some of the prestigious universities in the USA like Harvard and MIT, they have their own metrology labs for developing the specialized instruments, measuring instruments to measure the complicated sizes and dimensions. Okay. In this way metrology has got its own importance. Okay. I also want to tell you some of the universities are offering PhD program, especially in the field of metrology. Okay. Michigan State of University is offering the PhD program in the field of this metrology. And Oxford University is also offering a postdoc program. Okay. Like this, metrology is having, if you go for higher studies, metrology, if you take it as a research subject, if you take it as a research subject, then one can excel in that field of engineering called metrology. Okay. So metrology can be treated separately as a different type, different branch of engineering, strictly speaking. Okay. So this is all about the a brief illustration regarding metrology and measuring instruments, and also the various calibration techniques. Okay. And one more thing I want to say here is slip gauges. In your diploma level, you will not find slip gauges in any labs. But if you go for a higher studies, there is a lab called Metallurgy lab. In that lab, you will find slip gauges. Then after watching those slip gauges, you will come to an understanding that yes, in our diploma level, we were familiar with these slip gauges. Now we are in our BTech. Now in our BTech stage, we are using the slip gauges to measure the given sizes. Okay. So in this way, slip gauges are also having a vital role in the field of mechanical engineering. Okay. So apart from all these measuring instruments, there are certain other instruments which are used for the measuring some typical profiles of gear wheels and thread cuts, etc. Okay. So for exact measurement of profile of gear wheels or gear tooth or thread cuts, or you can say milling teeth, etc. Some of the universities are developing advanced instruments which will be useful for measuring the profiles of these gear tooth profiles and thread cut profiles. Okay. And also the this mill cut profiles. Okay. So with this, I conclude the today's session. Thank you.